So, I've just decided that I need a Commodore 64 in my life again. And after watching eBay for a while, I settled on a bread bin with a 1541 disk drive included. It was sold as a fully working unit and I paid nearly 100 euros for it, including shipping. And here it is now. Let's open it up and see what we got. So here's the main unit. It looks fine, seems to be intact. And here's the disk drive and some cables and the power supply. The power supply connector seems to be a bit broken, but that's fine. I plan on getting a replacement power supply anyway, since these old PSUs have a bit of a bad reputation. Before actually plugging anything in, I want to make sure that the PSU is working properly and is outputting the correct voltages. The way these PSUs tend to break is that the 5-volt output begins outputting a higher voltage, causing damage to the chips on board. So there's the 5 volts DC and the 10 volts AC. Here's the moment of truth. The Commodore is connected to my TV using the RF cable, so the picture quality will not be perfect. I will get an S-video cable later. Turns out I need to run a channel discovery to find the right channel. There it is. Now if I could remember how to use this. Oh. Still got it. Although I have a disk drive, I don't actually have any disks, so I don't have an easy way of transferring programs to my Commodore. So I think at first I should type in something using the BASIC. And here's what I found. It's a SID benchmark program which plays some audio. This is a good first program since I will get to see if my SID chip is actually working. So basically I need to type in these few lines of code by hand. So I guess I'll get to it. Success. So before even getting my Commodore, I had made this homemade cartridge. It's a PCB designed by BWAC, whom I'll add a link to below, with a dead test ROM programs on an EEPROM chip. It's designed to debug broken Commodores, but for my purposes it will now function as a generic test to see that everything is working okay. The dead test is running fine, but notice how the screen is all grayscale. I've later found that this seems to happen randomly on my Commodore, and I'm guessing there might be some problem with the chroma signal. I'll have to investigate this more in the future. Here's a look inside the Commodore. I'm definitely not the first one who's been in here. Most of the important chips seem to be socketed, except for the CPU here. Here's the VIC-2. The SID chip is here, covered by some heatsink compound. The shielding is acting as a heatsink, but I think in the future I might place in some beefier heatsinks instead. Scraped off some of the compound of the SID chip to get a better look at the version or the revision of the chip. Seems to be 6581 with no revision. Some research online suggests that this chip might be the 6581R3 since it has no extra markings and it's made in '84. And I think this is probably a pretty good SID chip, so I'm happy. Here's the back of the board with some pretty ugly looking flux residue or something. Made in England. And there's the serial number. Now I still have the problem of not being able to easily load programs to the computer. So a friend of mine pointed out that I could use a simple op-amp comparator circuit to load cassette images from an audio source. This way I could use a mobile phone as a sort of a cassette device. So he presented me with this schematic. Well, for me it's not looking so simple. There's so many resistors and whatever's here that it's going to be a challenge to set up on a breadboard. I actually tried and failed. So I went to play with the circuit simulator a bit and came up with this. This is basically a non-inverting version of the same circuit with much of the extra components removed. For basic functionality, we don't need all the current limiting resistors, the extra LEDs and the other stuff I don't even understand. This simpler circuit should work fine. And here's the result. But first, let's look at it in a simulator. And here's the circuit running in a simulator. There's 3 test points here. First of all, this is the audio input, running at just 2.5 kilohertz here. And second test point is the audio signal boosted up, right here. And the third test point is the output from the op-amp, which is here. It looks nice. Nice square wave with 5 volts max voltage. So, in theory, they should work fine. Here I have my phone connected to the circuit using a headphone jack. I'm using a Samsung phone, so if it blows up, nothing of value is lost. I'm using a function generator app, which is set to generate 2.5 kHz sine wave. Let's turn it on here. And here's the waveform on the scope. Next, let's turn on channel 2, which is connected to the output of the op-amp circuit. Looks good. Next, let's switch the audio inputs to an actual tape playback. There we go. The input is much worse than the sine wave, but the output is still looking very good. Sorry about the flicker, it's from the lights above. To connect the circuit to my Commodore, I will be using these crocodile clips. This is kind of a bad idea. If I short out some pins, then bad things could happen. But I'll be careful. Let's try loading Commando. I wish I had a joystick so I could actually play this game. Well, at least the music is good. But I think that's it for this video. Thank you for watching and see you next time.